Okay, so let's look at the last question on your FRQ review. So here we are looking at a graph, and the problem says a particle moves along the x-axis so that its velocity at time t for 0 to 6, because we're looking from 0 to 6, is given by a differentiable function, v. So we are looking at a graph of velocity. Is shown above. The velocity at 0 is 0. So our velocity is 0 at t equals 0, t equals 3, and t equals 5. Our velocity is 0. The graph has horizontal tangents. So at t equals 1, it has a horizontal tangent. And at t equals 4, it has a horizontal tangent. The areas, so area is going to be important if we need to integrate, of the regions bounded by the t-axis. So here's our t-axis. Instead of x, we're using t, but it's the same thing, same properties. And the graph of v, so that's our graph, on the intervals 0 to 3, 3 to 5, 5 to 6, are 8, 3, and 2 respectively. So the areas of these three portions are, the first one is 8, the second one is 3, and the third one is 2. It also says at time equals 0, the particle is at x equals 2. So that's where it starts. So starts, because t 0, okay, is where we start something, right? 0 time. And our position, so remember position, we write as s of t or x of t. And they've obviously chosen to go with x this time. Okay, so at x equals -2. So let's look at part A. For 0 to 6, so we're looking at this whole graph, find both the time and the position of the particle when the particle is farthest to the left. Justify your answer. Okay, well, A. What do we know? Well, they gave us a graph of velocity. What do they want us to find? Well, they want us to find time and position. Do we have a formula? Well, we don't really have an equation. We have a graph that we're going to look at, but we don't really have anything past that. So kind of our graph is our formula, or what we're looking at here. Let's think about our calculus step. So we got to kind of think about our velocity and position and all that. Well, if we want to go from velocity to position, well, that means we need to integrate. So we need to integrate the velocity. So that's our calculus step. We are integrating. But if we want to get something definitive, we're going to have to figure out a definite integral. Well, it says farthest to the left. So that kind of gives us a clue. So these areas here, so we have an area here, we have an area here, and stops at 6, so we have an area here. That's not pretty, but you know what I mean. And these areas, they've already told us what they are. From 0 to 3, that area is 8. And it's below the x-axis, so it's negative. From 3 to 5, that area is 3. It's above, so it's going to stay positive. And our last one, 5 to 6, is 2. It's below, so it'll go negative. Well, think about a number line. If we start at 0, well, all our positive numbers are over here. All of our negative numbers are over here. So when it says left, it's asking about this side, our negative side. So when we're talking about movement and we look at these numbers that we've given, well, left, moving left, when your velocity is negative. So when we find, or when our position is negative, I'm sorry, I said velocity. So when these areas are negative, that's when we're moving left, okay? So when we're looking here and we have this down here, this -8 means that our particle moved to the left 8 units, okay? So if we wanted to figure out some integrals, okay, because we're trying our best to use this graph to learn how to integrate, right? So we are integrating velocity in a hope to find position and where it's farthest to the left. Well, there are 2 times that we move to the left. Here, in this area, we move to the left, and here, in this area, we move to the left, because those are both negative. So either we always start at 0, so either we're going to be farthest to the left after the first time we move to the left, or after the second time we move to the left. So our 2 candidates here for the farthest left movement is either the integral from 0 to 3, because that's the first time, v of t dt, or our integral from 0 to 6, v of t, dt. Well, let's figure out where these are. So, our integral from 0 to 3 is the area from 0 to 3, so that's just -8. The integral is -8. And then from 0 to 6, we have to add up all these different areas. So we have -8, and then we add up the area plus 3, and then we add up the area, we add -2, which is just subtracting 2. So we have -8 plus 3 minus 2, and we get -7. So don't forget that our initial position, those aren't our positions, that's just where those were. At t equals 0, we started at -2. So to really get our position, so position is x of t, so our position at 3 is -2 plus the integral from 0 to 3 v of t dt. So this is -2, and that integral is -8. So that's -10. And our position at 6 is -2 plus the integral from 0 to 6 v of t dt. And we said that was -7, so this is -2 minus 7. That gives us -9. Well, the furthest left, the most negative, is here, and that's at time 3. So we combine all this, and we say that the particle is furthest left at, well, time 3, we plug in 3, so t equals 3, when the position is, well, position is x, so x equals -10. And that's our answer. So let's see if we did this correctly. So here is our rubric. So it says, since the velocity is less than 0 for 0 to 3 and 5 to 6, we consider t equals 3 and t equals 6, because, so that's what we said, like those were the times that we moved left, so that's what we needed to check. So we did end up with these two integrals. So we had our initial position plus the integral, initial position plus the integral, and then we had a conclusion, therefore the particle is furthest left at 3 when our position is negative 10. So did we identify 3 as candidate? Yes. Did we consider 0 to 6? Well, we did, actually. And your final point comes from the conclusion, and we did write a conclusion. In this video, we did at least. Okay, so we did get all 3 points for that part. Okay, so let's go back. Part B. For how many values of t where, so in between 0 to 6, so we're looking at the graph, is the particle at x equals -8? Explain your reasoning. Well, here's where I kind of drew out what was happening because I wasn't quite sure. So for part B, we know that we are kind of on a number line, okay? And they said that we start at -2. And then we said we move to the left. So if we start here and we move to the left 8, so we went -8, so that means we ended up at -10. Then the next thing that we did, we went from there, we moved to the right 3 because of that +3. So we went back and we moved to the right 3. So if we move to the right 3 from -10, we end up at -7. And then we moved to the left again, and we went to the left 2. So we ended up at -9. Well, they're asking us how many times did we end up at -8? Well, -8 is here. So how many times does it look like this number, this particle, passed by number 8? Well, when we went from -2 to 10, when we went from -10 to -7, when we went from -7 to -9. So that's 3 times. So this is all well and dandy, but we need a final answer and we need to use some calculus terms. So when does this particle move and why does it move and why does it cross -8? Well, the particle, because that's what's moving, the particle moves left from a position, so position is x, so it moves left from x equals -2, and then it goes to x equals -10. Then right, then we have this red thing, so then right from, where does it go? It goes from the position of -10 to the position of -7. And finally, it goes again, so from and left, sorry, I forgot my direction, and then left from x equals -7 to x equals -9. So what is that theorem that tells us if we pass over a number and our function is continuous, it's going to include that number? That's the intermediate value theorem. So we don't have to write all those crazy words out, I, V, T, there are 3 values. 3 values of what? What did they want us to find? How many values of t? So there are 3 values of t. For which the particle is at -8. And this video is getting kind of long, so I'm going to break up this last FRQ into 2 videos. So this is part B. Let's check against our rubric, make sure that we did part B, and then we will do parts C and D. So this says the particle moves continuously and monotonically. Okay, if we don't use all of this language, I think we're okay. It moves continuously from, so -2 to 10, and then 10 to -7, and -7 to -9. So we've talked about all these positions, t equals 3, t equals 5, and t equals 6. Description of motion, we said that it moved from the left to the right. So that description point, I don't know if we would really get that from here because we didn't use continuously. So maybe that's something that we need to go back and check, because our answer here, we just said that it moves, but it is important that it is continuous. And they told that to us in the beginning, but maybe we need to make sure that was part of our answer. So we might have lost a point there. But we did say by the intermediate value theorem, there are 3 values of t for which the particle equals -8, so we did get that. So we just need to be more specific when we are explaining how it moves. Okay. So just go to the next video if you're looking for parts C and D of this problem. We'll go ahead and do those.